Is someone there? Nagimi, Machikana.
Hello guys, how are you doing? Welcome to the maths lesson for tonight for grade 11. Can you all hear me?
Kwena and Nalidi.
Hello?
Yes.
Can you hear me, sir? Hello guys, can you all hear me?
Yes, sir.
Okay, thanks, Naledi. How about you, Marvin? Can you hear me?
Internet joining now.
Okay, yeah, they are. Welcome, Ethan. I think now is my good time to start now. Let me then quickly go to sharing my screen. Where's my textbook now? I share the screen. Can you guys see my screen that side?
Yes, sir.
All right, thank you. Then let me remove this question paper, this textbook here. Uh, I want to remove this one here. Okay, I'm left with this one. So we did. I have to which part last time? We did up to this part. So now we are going to start from here. We are going to do these examples on solving these riders. So they are saying there the following examples covers the most common techniques used in geometry by studying, mastering, and oh, fine. No, that's not important. But now this is what I want us to look at. So we have got this here. Let me do this. Oh, okay. So in example 11, right there, we are given that PR is a diameter. PR is a diameter. Okay, if PR is a diameter, and then now of the circle PRMS. PRMS, that is a circle with the center Q. And then PS, SR, and PM. PS, SR. Okay, are caught. Okay, and then PM. Where is PM? Here is PM bisect that angle. RPS right there. Okay, if it's 2x, then P1 will be x and P2 will be x, but they represented it now using those dots. Okay, now we are required to prove that PS is parallel to QM and QM is perpendicular to SR and QM bisect SR. Anyone with an idea, guys, of how maybe we can approach these riders? Any one of you guys who can tell us how we can approach this question? Oh, wait. Can you all guys hear me?
Yes, sir.
Okay, you can hear me. And you also, Naledi, can you hear me?
Yes, sir.
Oh, Naledi, why is it like you are down? What's happening? Is your weekend okay?
Yes, sir.
Oh, okay, thank you. Oh, I thought maybe it's somehow bad since your voice is a little bit down. So without wasting any time, guys, oh, this is what I'm going to do first. Oh, you already know what I'm going to do. DRCPT, the diameter, there is a diameter there in the circle. Therefore, that implies that this angle right here will be 90 degrees. Okay, we've got the radius as well. This will be equal to that. Therefore, that implies that this angle here would be equal to this angle, reason being angles opposite equal sides, or base of an isosceles triangle because of those radii. Then the cyclic quad, let me see. No, I can't see it, but guys, if you do see it, just shout it out so that I can fix that mistake. Then parallel lines, no, we don't have parallel lines that we are given. The tangent, you don't have tangent. So let's try to use the information that we just highlighted there and see what we can do. The first question, we are required to prove that PS is parallel to QM. Okay, guys, then now what can we do to prove that? Let's see what we maybe can do. Okay, if this angle, I can say now, let angle P2 right there be X. Then if angle P2 is X, I'm going to say my M1 is going to be equal to P2. Now, they are both equal to X, reason being angles opposite equal sides. Opposite equal sides. Do you guys agree to this statement and that reasoning?
Yes, sir.
Okay, thank you. And then now I'm going to say that angle P2 is equal to angle P1. This is an angle, that's an angle. They're both equal to X, given. Okay, then if now we did that, I can now say this angle M1 is equal to that angle P1 is equal to angle P1. Then my reasoning is going to be they are both equal to P2 to P2. They are both equal to that X. And then now, because this angle here, when we go to that other one there, now this one is equal to this one. Therefore, I can come to the conclusion that PS is parallel to QM. QM. My reasoning is going to be the converse of that Z is being formed by alternate angles. Converse of alternate angles. Then you are done just like that. Then you state your parallel equal angles because M1 is equal to P1. Then you are done. Does it make sense, guys, for this one?
Can you please repeat, sir?
Yes, sir.
Oh, okay, and a lady is asking me to repeat this question. Okay, let me repeat it for Naledi. So, okay. So, Naledi, here the question is requiring us to prove that PS, here is PS, is parallel. We are required to prove that line PS is parallel to line QM, right? So now what we are going to do, we note that QP is equal to QM. Do you agree to that?
Yes, sir.
Why?
Yeah, opposite equal side.
QP, the line QP, why is it equal to QM? These ones. This one.
Then
Sorry?
in this triangle, so these two are equal.
I'm
Almost
asking
equal
I'm asking why is PQ equal to QM?
because of this triangle.
Because
Of the triangle.
no, I disagree. Ethan, can you please kindly explain why are they equal?
Isosceles triangle. And PQ and QM is at the center.
Yes. So therefore PQ and QM will be radii.
Yes.
This length from P to Q and Q to M will be equal because there are two radius. Does it make sense now, Naledi?
Yes, sir.
Is that yes or no? You get it, Naledi?
Yes, sir.
Are you sure?
Yes.
Okay. Just don't be shy with anything. If you don't understand, I don't mind repeating it. So let me just emphasize that. If this is the circle, this is the circle. Remember we said the radius is the line from the center to the point on the circumference. That is the radius. So if there is this line OA, it's a radius because it's from the center to the circumference of the circle. Also OB will be a radius because that line is from the center to the circumference. And the radius is equal everywhere. Whether it's here or here or here or here or here will be equal. Therefore, this line will be equal to this line. That's what we are saying there in the diagram. So because PQ is the line from the center Q to the circumference P will be equal to the line from Q to M. That's radii. Then now when we have that isosceles triangle, this is an isosceles triangle because this was our radius QP and QM. These lines are equal. If those lines are equal in this triangle, that will implies that this angle will be equal to that angle. A reason being angles opposite equal sides or base of an isosceles triangle. Does it make sense now, Naledi?
Yes, sir.
Are you sure?
Yes.
Okay. Then let me wrap this. Let me erase this. Now I'm saying if PQ is equal to QM, you can say this angle is equal to that angle. So now what you can do, you can let that angle P2 right there be X. Okay. If this angle is X, that angle there also will be X. Therefore, we're gonna say angle M, no, not E, angle M1, angle M1 there is equal to X is equal to that angle P2 right there. Reason being, angles opposite equals equal sides. Okay. Does this part make sense to you, Naledi?
Yes, sir.
Okay. Thank you. Then now we come to this part. This this P1 will be equal to X will be equal to P2, then they are both equal to X. That one we are given. That one we are given. Then now, we have P2 here. We have P2 here. We have P2 here. Therefore, this M1 will be equal to that P1. Therefore, this M1 will be equal to that P1. Reason being, they are both equal to P2. They are both equal to angle P2. Does this part make sense to you, Naledi?
Yes, sir.
Okay. Now we say that angle is x. Then now we have this part, this angle here. And then we have that angle right there. This angle we are saying is equal to that angle. It brings us back to that maths is fun technique. Maths is fun technique. If they formed U, we're going to say corresponding. I mean, if they formed F, we were going to say it's corresponding. If they form U, cointerior. Now it forms something like N or Z with this shape because that angle is equal to that angle. Therefore, that implies that this line is equal to that, is parallel to that line. Therefore, now your conclusion is going to be PS is parallel to QM. Reason being the converse of that reasoning that you were going to use here. Converse of alternate angles. Now, instead of stating your parallel lines, because that's what you want to prove, you are going to state those angles that you are saying are equal. In this case, it's angle M1 is equal to angle P1. Then you are done just like this. Does it now make sense?
Why we are saying it's converse?
Because if I want you to hear me. If you don't understand what I'm saying, please just shout it out after I explain this. I'm saying that is a converse because let's say if you were given that line PS, you are given that line PS is parallel to the line QM. If you were given this, that this line is parallel to this one, and then maybe you are given this angle that is X. What was going to be the size of this angle here?
The size.
Yes, if we are given the size of this angle, that this size of this angle is X.
It also be X.
Yes, reason being,
Alternative angle.
yes, alternate angles, then you state those parallel lines. Only if you were given that these lines are parallel, now you want angles. Now, in this case of the problem, we want to prove that those lines are parallels and we have angles, meaning we do the reverse of this technique here. We do the reverse of the alternate angles. We want to prove the parallel lines, we have angles. I don't know if it makes sense or not.
Oh, it's because we are not given that it is parallel, but we have the angles.
Yes, we have equal angles. The parallel line is what we want to prove.
Oh, now I understand.
Are you sure?
Yes.
Okay, thank you. Then can I rub these guys to write, to use this space to write?
Yes, sir.
Okay. Uh, mm, my eraser is weak. Uh, all right, all right. Okay, okay. Okay. Okay, then the next question, we are required to prove that QM is perpendicular. Where is QM? Oh, here is QM is perpendicular to SR. Okay, I love this question. Any one of you guys with some idea of how we can prove this?
PR is a diameter. So
Oh,
P
okay.
so P is R is 90 degrees.
Yes, I 100%. Oh, not 50% correct. Okay. You are just going to say that angle is 90 degrees, or is there anything that you're going to say again? So you are saying that angle S is 90 degrees. So is this all? Or is there anything else that you want to say? Because you're not done here, Ethan.
Medium.
Remember I said in Euclidean geometry, you put statement and the reasoning.
Yes, sir.
So what is the reason behind that statement? It's angle in a semicircle, right? Angle in a semicircle. Angle.
Yo. Yes, sir.
Yes.
I
In
forgot.
yes, you forgot. You forgot. But no, it's not a big deal. We learn from our mistakes. And then now what's next?
Oh.
Because we proved that this line is parallel to this line. Can't we now conclude by saying these angles here, they form that F shape. Therefore, this angle will be 90 degrees as well, reason being corresponding angles.
We are corresponding.
Because, yes, because PS is parallel to QM. Does it make sense, Naledi?
Yes, sir.
Okay, thank you. Then, by doing this, we just proved that QM is perpendicular to SR. Then we are done
I
with this proof.
6.
Does it make sense, Ethan?
Yes, sir.
Okay, thank you, sir. Then we have got the last question here, QM. We are required to prove that QM bisect SR. Bisect SR. So anyone with an idea that you can say, okay, this bisects this. Oh, yeah, this one, I think, just bisects that one. Theorem 1. Do you guys still remember what Theorem 1 says?
Perpendicular from the center to a chord bisects the chord. The line.
Yes, yes, by just stating that reasoning, then you're okay. Then we can just quickly move to the other problems. Other problems. Oh, I've got example 12 here, the nice example I ever saw today. So we are given that long is a diameter, okay, of a circle LMT. The center is O, Tn is a tangent. Okay, and then Ln is perpendicular to NP. Ln is perpendicular to, meaning this is 90 degrees here. Okay, and then MT is a chord, then LT is a chord refers to P. Okay, now prove that MNPT is a cyclic quad. Okay, after that we are required to prove that NP is equal to NT. Anyone with an idea, guys, of how we can prove that? Naledi, you want to give it a try?
Oh, yeah. Okay, so
Sorry?
firstly, say I have this line
Okay.
n which is 90.
You're saying?
I have n which is 90.
Yes, there at N we have 90 degrees because of this information here. Where is it? Oh, here, because of this information. Hi, Mr. Ethan. Any idea?
Supplementary angles N1 and N2 plus T1 and T2 must be 180 because of supplementary angles or cyclic quad.
Okay, but before that, okay, this is already 90 given. Now, okay, why are you saying this is 90?
Because opposite angles has to be 180 because supplementary.
Which one? Oh, yes, I agree that opposite angles of a cyclic quad are supplementary. But, okay, the opposite angles that you are talking about are these ones, right?
Yes.
So now I want the reason behind this 90 degrees. Where did you get this 90 degrees here? Can you understand my question?
Yes, sir.
Oh, yes. I just want you to tell me where does that 90 come from? Can you see it, Naledi?
Yes, sir.
Can you see where does that 90 come from?
It's an opposite cyclic quad.
No. I disagree. So to save time, guys, we are given that this is a diameter. Therefore, this angle here will be 90 degrees. Do you agree? Angle in a semicircle. Do you agree to this?
Yes, sir.
Yes.
Okay. Therefore, this angle is a straight line. Now 180 minus this 90. I will be left with this other 90. Does it make sense?
Yes, sir.
Yes, then now you can come to the conclusion that you have said that this angle plus that angle is equal to 180 degrees, reason being opposite angles of a cyclic quad are supplementary. Then you are done with this part, just like that. Does it make sense, Naledi?
Yes, sir.
Okay. Then now with this one, we are required to prove that NP, where is NP actually? Oh, NP is right here. NP is this one is equal to NT. Okay. So we are required to prove that this thing here is an isosceles triangle. Okay. Then what can we maybe do? Oh, let's see. What we maybe can do. Let me think. Maths is fun. You can let this angle here be x, this angle here be x. Therefore, if this angle is x, in this triangle, the red one, this angle here will be 90 minus x, 90 degrees. Do you guys agree to this?
Yes, sir.
Yes, Naledi?
Can you please repeat, sir?
Oh, okay. I'm saying, okay, we are required in this case to prove that this line NP is equal to NT. Can you see that?
Yes.
So the only way I can see that we can be able to prove that we have to prove that this angle here is equal to that angle there. So in order for us to be able to prove that, we need to play around our angles so that we end up having this angle is equal to that angle. Are you cool with that? Are you cool with that, Naledi?
Yes, sir.
Okay. Therefore, now I'm saying let this angle here be x. This one here. So now this angle here will be 90 degrees minus x. Why this? Because the sum of all interior angles of a triangle is 180 degrees. So this 180 degrees minus the angle that we are having here in this triangle is 90 degrees here, minus 90 degrees there, and then minus that x there, minus that x. 180 minus 90 is 90 degrees minus x. That is why I'm saying this angle here is 90 degrees minus x. Does it now make sense to you, Naledi?
Yes, sir.
Okay, thank you. Now, if that makes sense to you, let's come to this triangle, to the whole circle LTM. And now this is a tangent to the circle. And then we've got this triangle in the circle, this triangle LTM. And then now we have got that angle there, that one. That angle, is it going to be equal to which angle? Is going to be equal to this angle here. Do you guys agree? Reason being Tan-Chord theorem.
Yes, sir.
Okay. Therefore, this angle will be 90 here. This angle will be 90 minus x, because it's between the chord and the tangent here. So does it make sense to you, Naledi?
Yes, sir.
Okay. If that angle is 90 minus x, now we want this angle here. And we know that the whole angle here, this one, is 90 degrees. We can just say T1 is going to be the whole 90 degrees for this one, minus this existing 90 minus x for this portion. We're gonna say that is 90 minus x. Therefore, this will give me minus 90. When I distribute those brackets, it will give me minus 90 plus x. This will cancel out. Then I will be left with T1 as x. Therefore, now we have got x here and we have got x here. Then now we can come to the conclusion that this side is equal to that side. This is going to be the converse of the base of an isosceles triangle. Does it now make sense to you guys?
Yes, sir.
Okay.
Yes, sir.
Okay. Are you guys sure?
Yes.
Yep, sir.
Okay. Thank you. Thank you guys for the feedback. Then let me quickly move to the this question. It might take us a lot of time, but let's give it a try, guys. We are given that A, B, A, C, D, B, and D, C are chords. And then you're also given that DE is perpendicular to, where is DE? DE is perpendicular to AC. Okay, 90 degrees there. And DB is perpendicular to FC. Okay. Now prove that DEFC is a cyclic quad. So anyone guys has an idea of how we can prove that DEFC is a cyclic quad? DEFC is a cyclic quad. Anyone with an idea, guys? Now, lady, don't you want to give it a try?
See, I have a bow tie here.
Oh man, that's a powerful approach. Where maybe so that I can highlight it. Which one maybe are you seeing?
DE
This one.
is equals to E. It's FC.
This one, eh?
Yes.
Oh
And
yes,
then
this is correct.
since I don't have a center, which is 90, that's 90 is equals to that 90 because angles in the same circle.
Semicircle.
In
Same
in a
segment. Same segment. So those angles are equal, reason being angles in the same segment. Same segment. Same segment. Angles subtended by the same chord. So in this case, the chord will be EF. Therefore, those angles that are equal is E1 and F2. That's the converse of angles in the same segment. Therefore, DEFC is a cyclic quadrilateral. Then you are done with this. Does it make sense, Ethan?
Yes, sir.
Okay, thank you. Therefore, now we are convinced that this is a cyclic quad. You're convinced that this is a cyclic quad. Okay. Then now the next question here, we are required to prove that AB is parallel to EF. AB is parallel to EF. So anyone with an idea, guys, of how we can prove that? Anyone, guys? Is it that challenging? I know it might be that complicated, but you guys, I have faith in you guys. You can give this question a try. What do you guys think? Already, are you now giving up? So, okay, where is AB? This is AB. Where is EF? Here is EF. Okay, now what can we do? If we proved that DEF is a cyclic quad, Do you guys agree if I say now this angle here, this one here, in this whole circle will be equal to that angle, reason being angles in the same segment. Do you guys agree?
Yes, sir.
Oh, okay. Maybe let
So much
this
progress.
angle be x, that angle will be x as well. Okay, the reason being angles in the same segment. Then now we come to this small cyclic quad here. Here, whereby we have this our imaginary circle here. And then again to this red circle, I'm going to say this angle x here is equal to that angle also here. Reason being angles in the same segment in this smaller circle. Do you guys agree?
Yes, sir.
Yes,
Okay,
sir.
yes. Then, therefore, now we are going to say this angle is equal to that angle. Reason being they are both equal to that angle x down there. Do you agree now to this?
Sir, you
Yes. Sorry?
didn't hear you.
Oh, okay. I'm saying we said this angle is equal to that angle in a bigger circle, reason being angles in the same segment. Okay. To this small circle, we proved that DEFC is a cyclic quad. We said this angle here, D2, will be equal to that angle there, E2, right? Yes. Therefore, now this angle E2 will be equal to that angle A there. Reason being they are both equal to angle D2. Does it make
Mm,
sense? Does it make sense, Naredi?
yes, sir.
Okay. Then now, after you came to this conclusion that this angle here, now you came to conclusion that this angle here is equal to this angle. They form that our f, that f of ours for corresponding angles. This angle, like this, ah, that is equal to this. Only if we are given that these lines are parallel, we can say this angle is equal to that. But or if we already have the equal angles, we don't have parallel lines, we can come to the conclusion that this line is parallel to this one. Reason being the converse of corresponding angles, then you state those angles that are equal. Does it make sense, guys?
Yes.
Okay, thank
Yes,
you.
sir.
Does it- Okay, thank you, guys. And now what I'm going to do, actually, I already did. I sent some problems that I want you guys to work on during the course of the week that we are going to. Are you guys there on the on that channel, the 2025 lessons, that channel?
Yes, sir.
Yeah, I just dropped some problems there that I want you guys to work on during the course of this upcoming week. The next time when we meet, can we just all do the corrections or discuss how you guys maybe have approached those questions? Now, lady, are you there on the channel?
No, sir. I wasn't able. I'm
Oh,
only in the group.
sorry?
I'm only in the group, the timetable group.
Oh, then I think I will ask Mr. Desmos to reshare it, or maybe you can just go back to the group and scroll there. You will check the link to the channel, then so that you can follow the channel because I post those problems there on the channel so that you guys can have some questions to do. So please maybe just go scroll there on the group. You will see the link for the channel. Otherwise, thank you guys for being with me tonight. I appreciate it, guys. I appreciate your cooperance. I will see you guys next week. Have a good night and a good weekend.
Night, sir.
Thank you, sir. Now logging out.